Hello, this is Lemar Jr. from Zimeco, and today we will talk with Vladimir Khorikov. Vladimir Khorikov is a Pluralsight author and recently wrote a very interesting book about principles, patterns, and practice about unit testing. Good morning, Mr. Vladimir Khorikov. Welcome.
Good morning. Thanks for having me.
Yeah, it's a pleasure. It's a pleasure. In your book, by the way, let me show your info here. In your book about unit testing, you made something very interesting, in my opinion. Today, the current year is 2020, and there are a lot of people reasoning about why adopting unit testing. There are a lot of people still reasoning about why adopting unit testing. But in your book, fantastic, by the way, you go far away this point, discussing some economic aspects. Could you share some of your thoughts about this subject?
Yeah. So I think today this conversation about whether or not you should do unit testing itself is not as prevalent as maybe 5 years ago or even 10 years ago, but it's still there. Yeah, I agree with you on that. What I see mostly is that this discussion shifts from whether or not you should unit test to how to do that correctly or how to do that in a way that makes sense. And with this book, I tried to answer this question. I tried to show how you can do the unit testing as you said, in an economical way, so that on one hand, you still have all the benefits of unit testing, but on the other hand, they don't drag you down. They don't slow down your project, and you don't have to spend too much time maintaining them.
Yeah, that's amazing. That's amazing. Do you talk about the costs of maintaining some unit tests? So you discuss about why to write or why not to write some kinds of unit testing. That's very interesting. By the way, changing the subject a little. What's the biggest impediment, in your opinion, for well-intentioned people who wants to write unit tests? What prevent them to write good unit testing today?
Yeah. So I think in the book I provided the 4 components of a good unit test, which you can use to assess any unit test or just test automatic test in your test suite. And these are how good they are at revealing bugs in your code, so protection against regressions, how good they are at not raising false alarms. I named this component resistance to refactoring, or you can also say that it is resilience to refactoring. And then fast feedback and maintainability. So fast feedback is how fast your tests are, and the 4th component is how maintainable your tests are. And the component that is least understood among developers is the second one. It's resilience to refactoring. So how to write your tests such that they don't raise too many false alarms. And this is this one I see a lot in the modern projects. So people write tests and they write a lot of them, but then there comes this point at time where you have to refactor something in your code base, and then almost all your tests are breaking. And they are breaking not because you broke something, but because you just wrote them in such a way that they bind to implementation details. And because you modified those implementation details after the refactoring, you basically have to rewrite all of those tests. And this comes up a lot when you mock internal communications between your domain objects, and when you bind to other implementation details. And that's the biggest factor that I see nowadays that contribute to people writing not maintainable tests or not valuable tests.
Yeah, I got it. But people still talk a lot about having a good level of code coverage. And people usually associate a high level of code coverage with good tests. But this is not true. And your book, you provide a lot of guidance about how to analyze the quality of tests and the use of code coverage. Could you talk a little bit more about coverage and your considerations about that?
Yeah. In the book, I showed that code coverage, it's a metric that is better than nothing, but it works in only one direction. It's a good negative indicator, but it's a bad positive one. And what I mean by that is that when your test coverage number shows some small number, something less than 50 or 40%, then it's a good indication that there is something wrong with your test suite. You're not testing enough. And that's what I mean by good negative indicator. But it's a bad positive one, because even if your test coverage shows some high coverage number, something like 90 or even 100%, there's still no guarantee that the test suite, your test suite, is good enough. And as I said, I saw a lot of projects where you have lots of tests and they cover your project pretty much 100% with 100% code coverage, but they still are hard to maintain because of this second component, because they are not resilient to refactoring.
Yeah, I got it. What are your considerations about legacy code? There are a lot of code bases over there with no unit testings at all, and the code coverage is zero. Where to start? What should be a good start point to start to cover legacy code with tests?
Yeah, there is another great book. It's from Michael Fathers. It's called something like "Working Effectively with Legacy Code," and it speaks to this point: how to start writing tests in a project that doesn't have any tests. And one of the key takeaways from this book is that you need to identify themes in your application. So the borderline between something like the view or UI and the domain logic, and that is something that you need to do anyway when you refactor your legacy application, and this will also help you to cover your to start covering your project with unit tests. Another approach that you can take is that, so in the book I said that I showed that it's pretty hard to write valuable tests when your code is written in not an optimal way. So when it's entangled with hard-to-test dependencies, it's pretty hard to separate the two and start writing good unit tests. And so to write good unit tests, you also almost always have to refactor your underlying code base. But that introduces a circular dependency, because now in order to refactor your underlying code, you have to have some tests, because you need to make sure that your refactoring is correct. And on the other hand, to write good unit tests, you need to refactor your code. So how to resolve this circular dependency? In this case, I recommend that you start with end-to-end tests. And so if you picture your tests in your test suite as a test pyramid, the highest level is the end-to-end tests. They are the tests that normally you should have only a small number of them, and they should go. They should test your application end-to-end, including the user interface, any external dependencies, something like such as the database, and so on. And so when you don't have any tests at all, and when your project is written, it's too entangled, the domain logic in that project is too entangled with hard-to-test dependencies, you basically don't have any other choice other than to start with those end-to-end tests. And you can definitely do that. So this is a good approach as well. You as I said, you start with end-to-end tests and then refactor your underlying code, and then start to push those tests down the test pyramid. So you start to replace end-to-end tests with integration and unit tests, and then remove those end-to-end tests altogether. And this is also a good approach. It will help you to both refactor your project, the code of the project, and also to put some valuable tests, unit tests and integration tests.
Yeah, amazing, amazing. You mentioned the Michael Fedor's book, and that was published some time ago, a long time ago, I think.
Yeah, it's an old book.
Yeah. What changed since the book was published? What should you consider before reading that book and don't getting in a wrong way? Mike Fedor shares a lot of examples written in C++ or in other technologies. And today, I write code in C#. I think your examples are in C# as well.
Yep.
What changed from the Michael Fedor's book, and we need to take in consideration before following his recommendations? Do you think something relevant here? There is something relevant here?
Well, his recommendations are, a lot of them are still relevant for sure. What changed, I think, well, technology changed for sure, but in terms of the attitude, I would say that you see much fewer projects that don't have any tests in them. Even legacy projects that you inherit from some other developers, you still see some tests, and sometimes there are a lot of them. And I'm not talking about projects with good code quality. So those are definitely have unit tests in them. But even projects with lacking code quality, they still would have some unit tests or integration or end-to-end tests. And so right now it's less of a question how to start introducing tests to those projects, but how to refactor those tests along with maybe the code base itself, so that you will have better quality tests. So that's at least my experience nowadays. I'm not sure if it applies to every team. Probably not, but at least that's what I see nowadays.
Yeah, that's amazing. You started talking now about refactoring unit tests, and that's a very interesting point, because code or tests or code anyway,
Yes.
and it needs some maintenance, and there are a lot of costs involved with maintaining good code for unit testing or any kind of testing, by the way. This point of view, considering that tests or code is something interesting, because people don't use to think about maintenance of the...
Exactly, yeah. And oftentimes people assume that tests are some addition to their production code, and they don't need to pay too much attention to the quality of those tests. Whereas in fact, it's as I said, tests are your code. So it's you have to pay as much attention to your tests as you pay attention to your production code. And you need to write them such that they are clear, they are highly maintainable. So yeah, basically approach them the same way as you approach the production code. There should be no difference. Yes.
Yeah. That's amazing. You have been talking about DDD for a long time as well. You have courses in Pluralsight about DDD, domain-driven design. And how do you relate domain-driven design with unit testing? Could you talk a little bit about this?
Yeah, that's actually fascinating, because not two, but three areas of programming I find that they are related to each other quite well. So if you take domain-driven design, unit testing, and functional programming, they all have some central theme in them, such that they all preach for separation between your domain model and out-of-process dependencies. And it's even more evident in functional programming, in such functional languages as, for example, Haskell. They have even a built-in language construct. It's called IO. IO construct that tells you if this particular code refers to the external world, so to any input-output, such as, for example, the database. And so, for example, if you try to call this IO method from another method, it makes the caller an IO method as well. So it works in only one direction. You cannot make a pure method call the impure one, because that impure method makes the caller an impure method as well. And so why it's important, the importance here is kind of the functional programming, domain-driven design, and unit testing. They view this importance from different angles, but still they coalesce to this central point of the separation between the two. In domain-driven design, why it's important is because your domain model is the most important part of your application. And so it's important to keep it separated from any other responsibilities, basically from anything else other than the domain modeling. And so your domain classes shouldn't be responsible for saving, let's say, themselves to the database. They shouldn't be responsible for querying some external service, anything like that. So any infrastructure code, any code that works with out-of-process dependencies, it should be separate. It should go separately from the domain model. And as I said, the reason is that the domain modeling responsibility itself is complex enough, and you shouldn't include any more responsibilities to your domain model, because that would make your domain model exponentially more complex. And domain-driven design is all about complexity, managing complexity. So, and in unit testing, you see this subject too when you separate out-of-process dependencies from the domain model, but for different reasons. So here you are seeing that this recommendation, because when you separate out-of-process dependencies from your domain model, it becomes much easier to unit test that domain model, because one of the characteristics of good unit testing, of good unit tests, is how many collaborators they work with, and the type of those collaborators. If you're trying to test, let's say, a user class that works with the database or with some message bus, it becomes harder to test it, because now you have to either maintain that database to set up some test data in the database and stuff like that. Or if you mock the message bus, you will have to write complicated mock machinery, which is also quite hard to maintain. And so your tests become larger. And in order to reduce the size of those tests and therefore make them more maintainable, you need to separate the two. And now when you do this separation, when you implement this separation, now you are able to unit test your domain model directly without involving all those out-of-process dependencies, without thinking of them. And you can push this responsibility of testing how your domain model works with those out-of-process dependencies to integration tests. So you can push it higher, the test pyramid. And this is much more, I would say, economical, because now you can have a lot of unit tests, quite a lot of very cheap unit tests, which are still very valuable because they test your domain model. And you still can have integration tests that verify how your domain model works in integration with those out-of-process dependencies. And so your test pyramid now starts to work really well. All those different types of tests start to complement each other. And the major way, so the main way to achieve this separation is to, again, separate your domain model from out-of-process dependencies. So there I find it fascinating how all these areas of programming, they coalesce onto each other, and they preach for the same thing, but for different reasons. That's really fascinating.
Yeah, that's really amazing. That's really amazing. Can we understand that the most important part of the code base to test is the domain model? Do you agree with that? Should we start with the domain model, and if we have an additional time to start to test other parts, or is that wrong?
This is definitely true. So I would recommend. So there are two ways to approach your development of your application. First is an old school way. When you start with a database, you come up with your data structure. So let's say if it's SQL database, you come up with the structure of your tables, the relations between them, and so on. And the second, more, let's say, modern approach is to start with your domain model. And this is a better approach because, as I said, your domain model is the most important thing, and you should start with your domain model and then go outside. So this approach is called, I think it's called middle out development. So outside, you have outside in, inside out, and this one is middle out. So similar to inside out when you start with the bottom layers of your application. But here, the domain model is in the center of your application, so that's why it's called middle out. So yeah, you're basically what I would recommend is that you should start with the domain model and try to maybe model your domain with some large scale strokes when you just try to see how it may look eventually. And then at this point, you probably don't need to even write any tests. And then when you have a good understanding how your domain model looks, then you can switch to outside-in development and try to write one feature that is small as possible, but it works with all layers. So it works with your domain model, it works with the database, and this is something that is called your application skeleton. So you build this skeleton, and then you will be able to see how your application will look eventually. So you will have a thin slice of all components in your application. So a thin slice of your domain model, of your database, and maybe even some UI. And yeah, so basically that's how I would approach. How I approach all software development nowadays. So build a thin slice of some feature that touches upon all layers in your application. Then, and when you build this thin slice, you still start with a domain model. Then you add a database and cover all that with integration and unit tests.
Yeah, fantastic. In your answer, you mentioned the UI, and these days the front end is getting more and more complex. I don't know if you agree with that, but what about the unit testing for the front end code? What's your recommendations about that?
That's a good question. I don't have a lot of experience with front end development, unfortunately. So last time when I touched front-end development, it was server-generated HTML, like classic ASP.NET, stuff like that, and also WPF Windows applications. That's where I stand currently in my knowledge of UI development. So I looked a little bit how modern React applications work. They are pretty modular as well, and that's really good. But I'm not sure how I would approach testing them. I would need to get into the weeds more to start recommending something, because nowadays I'm mostly involved in backend development, in API development.
I am also a backend developer. The last time I tried to design something for the front end, I used some kind of tables in the HTML. So today I think it's not correct, but it works.
Yeah.
But it's not my game as well. Talking about microservices, there are special considerations about unit testing or testing at all for microservices. What you recommend? What's different when talking about microservices and testing?
Well, I don't think there is anything different. So you should approach microservices, every single one of them, as a separate application. And when this microservice talks to other microservices, that's where you need to apply. I talked in the book when you should apply marking and where you shouldn't mark some out-of-process dependencies. And the main point is that all out-of-process dependencies can be categorized into managed and unmanaged out-of-process dependencies. And managed dependencies are out-of-process dependencies, communications with which are not observable externally. So, for example, your application database is a managed out-of-process dependency, because when you talk to that database, the result of that communication is not visible to anyone, because all external applications, they go to your database through your application. They don't go to your database directly. And so communications with managed out-of-process dependencies should not be marked, because those are internal implementation details. And you should test how your application works with those dependencies directly. So your integration tests should should set up your database and then verify the state of that database when the test is over. So the second type of out-of-process dependencies is is unmanaged dependencies, and that is out-of-process dependencies, communications with which are visible to the outside world. And that's a typical example is something like an email, an SMTP service, or a message bus. And because these are the applications that are built specifically for that reason, so that when you communicate with those applications, those communications are visible externally. Because when you send an email, then the person who you send this email to, they should be able to view this email outside of your application. And so when we're talking about microservices, different microservices are also unmanaged dependencies for each other. And so when you talk to another microservice, you need to mark this communication out basically check what calls you make to those microservices, and if it's an asynchronous communication, what messages you put on the bus for those microservices to observe. One thing that I think is different here is that it becomes the end-to-end testing becomes more important than with a monolith application, and that's because there is much more, many more moving parts, many more microservices, and there is more. So you have more room for a mistake between where your application communicates with those external microservices. Whereas when you build a monolithic application, you can pretty much be sure that the only dependency, out-of-process dependency you work with is your database. But that's not the case with microservices. And so here I would say that the number of end-to-end tests that go through all your microservices, but maybe not all in each test, but still at least some of them. So the number of those end-to-end tests is larger when you do microservices architecture compared to when you just do a typical monolithic application, because it becomes more important to test how they all integrate with each other. And also another approach that I think it was proposed by Martin Fowler. It was that you can introduce service contract tests. It's when you ask another team. So let's say you develop a microservice that is consumed by another microservice that is developed by another team. And so you can ask that team that consumes your application, your microservice, you can ask them to provide you with examples of those requests. So let's say they want you to provide them with I don't know, with a product catalog, or they want you to build a functionality for modifying that product catalog. So you can ask them to give you examples of those calls, so including just the data contracts. And so you include those calls to your test suite, and then they become a part of your test suite. They run constantly, and they make sure that when you emulate this call from that second team, your application responds correctly. So it responds with the same data, let's say when they request a product catalog, and also the side effects of the modification, they still remain the same. So yeah, I would say these are the differences between a typical monolithic application and microservices architecture in terms of testing.
Fantastic. Very good. Man, one last question. You have been teaching people how to write better software for a long time, and I would like to know if what are your recommendations for people who want to write better code? How to improve the skills to write better code? We know that you consider testing a very important thing, but besides of tests or including tests, what would be your recommendations?
Yeah, that's a really good question. I would say that you definitely need to learn domain-driven design. That's another topic that fascinates me personally a lot, and also functional programming. So all these areas are interconnected with each other, and you cannot achieve mastery without looking into all these three areas. So I'm trying to think what else. Yeah, most of other topics, let's say some technical stuff, you can learn them on the fly, basically, because they change more often, and there shouldn't be any issues with learning some new stuff when you already learned the previous generation stuff. But these concepts from domain-driven design, from functional programming, from unit testing, they are essential. And I would say you will be able to reuse them in a lot of projects, and they don't change often. So if you learn them once, you will be able to apply them in pretty much any of your project.
Yeah. Recently, in an interview, you recommended us to look at F#, but now C# is getting more and more functional, or getting more and more functional behaviors. I don't know how to say that in a correct way, but C# is getting more and more functional. Do you agree with that? Is that a movement that we can expect? What are your opinion about that?
Yeah, C# has been borrowing a lot of features from F# for a long time. Yeah, that's definitely true. But there still are some differences. And the main difference, I think, between the two languages is that C# is still an object-oriented language, first language. So its default approach is to follow a typical object-oriented programming approach. That's not a bad or a good thing on its own. It's just something that keep in mind. Whereas F# is functional first language. And so even though you can do pretty much, well, not all, but a lot of things that can F# do, so you can do them in C#, you're still have to put some additional effort into that. And still, there are some features that are in F# and other functional programming languages, like, for example, union types, that are not, they are not in C#. Or, for example, handling not nullable reference types. You we are start having them some support for that in C#, in C# 8, but it's still not the same level of support as in F#, where it's built into the language itself, and where you basically cannot use a null anywhere. That's what was done from the very beginning, and this will help you guide with building better quality code, and that's a pretty good difference, because again, the difference I would say is that in C# you have to constantly put some effort into maintaining the quality of your software, whereas in F# you don't have to put as much effort as in C#, because all those concepts that you go with them by default. And let's, for example, another concept is you have immutable types that are immutable by default, and in order to make them mutable, you have to put some additional effort. So you have to, in F# you have to put effort to break those best practices, so to violate them, whereas in C# you have to put effort to follow those practices, and that's the main difference, I think, between the two languages.
That's a very good point, man. Thomas Petruchek, who is a guy who writes about a lot about F#, says that a good starting point for who wants to learn F# is start to write unit tests in F#, testing C# code from F#. Would you recommend that? What do you think about this?
Yeah,
I'm not trying to make a point between you and Thomas Petruchek. By the way, it's just a question. Would you recommend to write codes in F# to C#?
Yeah, I think I read about that, maybe from Thomas or maybe from Scott Vlashin, I don't remember. So yeah, they recommend if you want to gradually introduce F# into your organization, you may start writing unit tests in F#. So not the production code, but unit tests. And I think that's a good recommendation, but you have to keep in mind that in F#, all your tests follow the output-based testing style. So when you have some input, some arguments, and have some outputs, and that's basically it. You need to provide an argument and then verify the output. In C# you also have a lot of communication-based testing when you need to set up some mocking, and state-based testing when you have to verify the state of your system under test after the test is completed. And that's something that F# is not as good with. So F# is perfect when you have output-based testing, because that's basically the functional approach, when you just provide an input and verify the output and you don't mutate anything. And for this functional approach, yes, F# is perfect. But again, you usually don't have very many of such tests. And in C# you will also have a lot of state-based testing and communication-based testing, for which F# is not as good as just regular C# tests.
Okay. I'm sharing in the screen right now the address of your website. I think this is the best way to get in touch with you and to learn more about your trainings, about unit testing and DDD and all the technical stuff. I think are there some are there some additional points that you want to talk about, or do you think what we have now is good enough?
Let me think.
Did you miss something?
No, I don't think so. So yeah, all great questions. Fascinating discussion. I'm trying to think what else. Yeah, we covered pretty much all I wanted to talk about today. So yeah, we're good.
So thank you, Mr. Vladimir. It was a pleasure to learn from you. It's fantastic to learn about unit testing and good testing practices. It's fantastic. Thank you very much for your time.
Thank you for having me, LMR. It was a pleasure to talk to you. Thanks.
Bye-bye.
Bye.
So